Hello class, today we are going to talk about the angles of chords and secants. So what we're looking at here is the angles that are made when you have chords of circles and secants of circles. When those intersect, what are the angles? All right, so let's take a look here. If two chords intersect inside a circle, then the measure of the angle will be half of the sum of the intersected arcs, okay? So let's just put this as a formula a little bit easier. There we go. So what this means is that angle C right here is half of the sum of arc A plus arc B. All right. Notice it's not going to equal. This is not a central angle there. If it was a central angle, then it would equal the arc, right? But that can't happen because A and B are different. And these angles, those are vertical angles. Those are congruent, right? So clearly it's not going to equal because this angle equals that angle, but the arcs are different, right? So it's got to be something different. What it is the sum of the intercepted arcs. Also, very important, it goes like this. So if you could draw an angle through the line, through the arc, through the angle, to the other arc. We're not going to be using this arc here or that arc there because those are not the arcs intercepted by this angle. All right, those would be the arcs intercepted by these angles. Okay, so the measure of the angle is 1/2 the measure of the two arcs added up. So let's do a couple of examples here. So we're going to find x. So x is for this arc right there. So the angle x is equal to 1/2 the sum of the intercepted arcs. So that would be this angle intercepts that arc, this angle intercepts that arc. So we're going to take 146 plus 58. We're going to add those up, and then we're going to divide it by 2. So let's see here. We could just take that, stick that in our calculator, right? And so x equals, well, we're just going to break it down. 1/2 of 206, and x is equal to 103 degrees. All right? So there it is. Not too bad. Pretty easy stuff. Let's take a look at this next one. Slightly more complicated, not much. So here it wants us to find one of the arcs. Okay, so let's see here. We have, it doesn't give us the angle. It gives us one arc, gives us an angle, but this angle right here, that is for this arc, not one of the arcs that we're looking for, right? So we need to find out what one of these two angles is. Well, this is a straight line, so they're supplementary. We can just subtract it from 180. So 180 minus 137, and that is 43. All right, so this is a 43-degree angle. So now, let's see here. The angle, 43, is equal to 1/2 of the arcs added up. So that'd be x plus 63. Okay, so we could distribute the 1/2 in there, but I'd rather not just deal with that 1/2. So instead of dealing with that fraction, I'm going to multiply both sides by 2. So times 2 on both sides, and that way I don't have to deal with the fractions. And so that gives me 86 is equal to x plus 63. We're going to subtract 63 from both sides, and x is equal to 23 degrees. All right? Clearly not drawn to scale. All right, so that's what happens if we have chords intersecting inside the circle. Let's take a look at what happens if chords intersect outside the circle. Well, not chords, secants or tangents intersect outside the circles. Obviously not chords. Chords are only on the inside. So if two secants or tangents intersect outside of a circle, the angle will be half the difference of the intercepted arcs. All right? So we've got 3 situations here, either using both secants, both tangents, or a secant and a tangent. Either way, doesn't matter. What you end up with is 1/2 the difference of the arcs. All right. So you take the two arcs, you subtract them, divide by 2, and that will give you the difference of, that difference will give you the measure of the angle. All right, so let's clean that up. Now, one thing, order of course matters. Our measures all need to be positive, so it's always going to be the larger arc minus the measure of the smaller arc every time. That way, all of our measures come out as being positive numbers because we don't have negative angles. All right, so here we go. Let's work out this one. We want to find the measure of the angle. We have the two arcs, so we're just going to plug it in. So 1/2 the difference of the arcs. So x is equal to 1/2 282 minus 87. All right. So x is equal to 1/2 of 282 minus 87, which is 195, and half of that, x is equal to 97.5 degrees. Again, obviously not drawn to scale. I just throw stuff up here and make random numbers. 97.5 degrees. Easy enough. So let's take a look here. Here it gives us the angle, and it does not give us one of the arcs. So my angle, 17, is equal to 1/2 the difference in the arcs. Now the question, is it going to be x minus 42 or 42 minus x? It's going to be x minus 42. This arc is the larger arc. It is the arc that is farther away from the angle, so the angle is open wider, so it's going to be the bigger one. So we have x minus 42. Alrighty, I could distribute that 1/2 in. It would come out okay, but still I'd have to deal with that 1/2 because I have 1/2 x. So instead, once again, I am going to take this and I'm going to multiply both sides by 2 to just kind of cancel that out, right? And so that gives me 34 is equal to x minus 42. Add 42 to both sides, and we end up with 76 equals x. So this is a 76-degree arc right there. All right, let's take a look at one more. Okay, so here we have two tangents. Still, 1/2 a minus b equals c. Remember, c is the angle. So we have 43 equals 1/2. It did not give me either one of these arcs, did it? So how are we going to do this if we don't know either one? Well, we can kind of figure this out because we know the entire circle, right? The measure of the entire circle is 360 degrees. This little bit is x, so the rest of the circle, this part here, must be everything else, right? So what this over here is, this is 360 minus x. So let's just put that in here. So we have 360 minus x. So that's the big arc minus the little arc. And the little arc is x, right? So minus x right there. Okay, so let's do that. I'm going to simplify this before we solve it. So let's see, 43 equals 1/2, 360 minus x, so that would be 360 minus 2x, right? Well, you know what, 360 and -2, those are both divisible by 2, so I'm going to go ahead and distribute the 1/2 in. All right, so if I take this 1/2 and I distribute that in, well, that will give me 43 is equal to, well, half of 360, that's 180, and half of 2x will just be x. All right, so now that is a lot easier to solve. So all I have to do is, okay, so we're going to subtract 180 from both sides. So that gives me, what, 137, negative 137, equals negative x. We don't want negative x, we want positive x. So we multiply both sides by -1, and we end up with x equals positive 137. So this is 137 degrees. Real quick, what's the measure of the other arc? Yeah, it's just 360 minus x, so 360 minus 137, which would give us 223 degrees. All right. Now, I do want to point out something right here, this line here. Notice this simplified down to where the angle is equal to 180 minus x. If you have two tangents, which is what we have here, all right, we have two tangents intersecting, so we're using the entire circle, then the measure, if two tangents intersect outside of the circle, the measure of the angle is the difference of 180 and the measure of the intercepted arc. So it does shortcut a little bit. What we can do is just jump straight down to this line here. All right, just take the angle, subtract it from 180, and that is going to give you the smaller angle, the minor angle there, the minor arc. All right, it will not give you the major arc, but the major arc you just subtract it from 360, so not a big deal. All right, so that is that. So just to refresh, if your lines intersect outside of the circle, then your formula is 1/2 the difference of the two arcs. So you subtract the two arcs, divided by 2, that will give you the angle. If your segments intersect inside the circle, then you add the arcs and divide by 2. Either way, you're going to divide by 2. It's 1/2 the sum if they're inside, 1/2 the difference if it's outside. All right? Hopefully you found that useful, and I will see you in the next video.